So in this video, I'm going to go over the synthesis, storage, and circulation of vitamin D and touch on the chemistry and composition of the skin. Okay, so we're going to start with the epidermis. Now the epidermis' primary function is to protect us from infection, and it also helps us regulate the amount of water released from the body, and it does not have a blood supply. So the epidermis is made up of 90% of these cells called keratinocytes, and it's these keratinocytes that are really high in a type of cholesterol called dehydrocholesterol, 7-dehydrocholesterol. Again, it's the 7-dehydrocholesterol that is primarily found in the keratinocytes. Now, when this type of cholesterol is bombarded by rays of the sun, it can be converted into something called pre-vitamin D. Now, pre-vitamin D can then be converted to cocalciferol, or the inactive form of vitamin D. Now, it's cocalciferol that is the what you would find in a supplement. But if we are getting too much vitamin D into our system, this pre-vitamin D can be converted to lumisterol and tachysterol in the dermis. And that is a way for us to store vitamin D. Again, as these two other chemicals here, tachysterol and lumisterol. So the skin is one place where we can store vitamin D. The other places include fat cells of the liver, the brain, and the bone. So again, the skin, fat cells in the liver, brain, and bone are all places where we can store vitamin D. Okay, so cocalciferol, again, in the epidermis is moved into the dermis. Now, the dermis actually has a blood supply to it, and that's where it's eventually going to be dumped into the bloodstream. But I want to go over these cells on the left side of the board here because the dermis is primarily made up of these fibroblasts, macrophages, and mast cells. So fibroblasts are critical for wound healing, and they're also essential for collagen production. Macrophages are a type of white blood cell, and mast cells are also part of the immune system, and they are high in histamine and heparin. Now, heparin is a long carbohydrate chain or a polysaccharide. It is a type of glycosaminoglycan, and it also acts as a blood thinner. So this all comes from mast cells, which are primarily one of the main cells of our dermis. Again, these mast cells are actually made in the bone marrow, and they migrate all the way to our skin. So that's the dermis in a nutshell. So we have, again, this cocalciferol, this inactive form of vitamin D, which ends up being picked up by the vitamin D binding glycoprotein over here, which is synthesized in the liver. So again, the liver synthesizes this vitamin D binding glycoprotein. And when I say glycoprotein, that means that it is a protein that requires carbohydrates. And this is released from the liver, and it eventually moves its way to the dermis, where it can pick up this inactive form of vitamin D. And it's the vitamin D that eventually, with this binding protein, that enters our bloodstream and circulates freely in our bloodstream. Now, one point here is that estrogen actually helps raise the production of this vitamin D binding protein, but liver disease, trauma, nephrotic syndrome, which is highlighted by too much protein in the urine, malnutrition, and septic shock are all diseases that will actually lower the production of this vitamin D binding protein.